I know that you're a world-class expert on 3D printing and you've done some work in medical devices. So what kind of impact is 3D printing having now in the world of medical devices?
Sure. Well, thanks for having me on. I think there's two big areas where 3D printing is having an impact. One is with actual prototyping and helping uh, get products to market faster. And I think the other is really on end production, where companies are using more advanced technologies that print in titanium or high performance polymers that you can actually think about using the end results from the printing process for an implant or for a prosthetic or in applications where it's in the field, it's being used, it's being applied for end production. And so delivering some of those capabilities that 3D printing generally offers, where it's more customizable or you have some complex geometries that take advantage of some sort of applied improvement, really has been increasing in interest and application throughout the industry over the last few years.
That's pretty cool. So when I think about medical device manufacturing, let's say most mechanical parts end up being like injection molded or something like that. And you'll have to go through an IQ, OQ, PQ process, for example, on the line to look at how things are coming out, make sure that they're consistent. How does that work with 3D printing?
Yeah, it's a big challenge. For one, the standards surrounding the technology are still evolving. So the ASTM or ISO standards, there's some kind of mishmash that are coming together, but generally that's improving, but not fully flushed out. And I think the one great thing about 3D printing is you can make a part without a tool and you can make customized parts. Like that's the big advantage of it, but it's also in some ways a nightmare from a qualification perspective because you have a lot of different variables in the process because if you think about it, whatever process you're using, whether it's a filament or a powder or a liquid, you're kind of building the material and the part at the same time. So what you start and as an input is different from the output. And so you have to think about things like what material is going in, your design consideration, which way you build it in the printers. There might be different geometry implications, and then even the machines and repeatability and how you want to inspect it at the end. So we're doing a lot of work in that space, and medical aerospace are big areas where the qualification conversation around 3D printing is really fueling, and in some cases purposely delaying kind of the potential applications that we have to ensure that we can make sure that the parts are safe, that they're repeatable, and that companies can have confidence in using the technology for particular applications.
Hmm. Have you had any experience to date with a regulatory submission to FDA and seeing what the feedback looks like?
So we haven't had direct impact. So what we're doing is we sit on a number of the standards committees, so helping people connect with the technology and the materials and putting all that together and the testing behind that. But we've also developed some software tools to help organize that data. So for any kind of 3D printed build, you have about 100 different variables that could impact the outcome of the part, either mechanical properties or fit or form or surface finish. So we've built some software tools called Trace AM that do that. But at the same time, where we've started with applying that technology is in the medical space, just because it's so relevant. So we've done kind of two projects. One with an infant helmet that was for a kind of a design prosthetic that we could customize for infants who have flat head syndrome. So we've worked with that kind of approach with a university up here in Illinois, Northern Illinois University, to kind of benchmark what do we have to document there and kind of moving that along. And then we've also done some work in the dental space, which is kind of a big area, a big industry in 3D printing to build some, I would say, more devices, not necessarily implantable, but kind of scanning devices and ease of use devices for application in the theater.
All right, that's great. So if somebody's in the business of manufacturing medical devices and considering 3D printing, that's something that you and your company could help them think through?
Absolutely. I've been in the space for about 12 years. I have a PhD in material science focused on 3D printing. I started a company about 8 years ago called 3 Degrees. And our kind of day-to-day job is helping organizations think through the opportunities and kind of helping them plan out where best, or if it's a good solution at all, to use the technology.
Awesome. Well, thanks a lot for your time, Mike.
Thank you.